Okay, so here we need to explain some examples on the linear differential equation. So suppose we have one example. One question is to find the general solution. Find the general solution of the differential equation which is dy by dx minus y, that is equals to cos x. So here we can say that it is obviously in the form of a linear differential equation. So this should be dy by dx. So this is a linear differential equation of the form dy by dx plus py, that is equals to q, where p and q are functions of x. So here p is nothing but -1 and q is cos x. So now, therefore, the integrating factor we need to find, that would be equal to e power integral p dx. So that would be e power integral minus dx. So that would be e power minus x. So this is the integrating factor. And the general solution of this type of a differential equation is given as y times the integrating factor, that is equals to integral q times the integrating factor into dx plus c. So therefore it will be y into e power minus x, that is equals to q, which is cos x into e power minus x into dx. So that would be y into e power minus x, that would be integral e power minus x into cos x dx plus the constant of integration c. So now let's find the integration of this. Let's say it is I, which is equals to e power minus x into cos x dx. So here we need to find the integration by parts. So this we have to take it as a second function. We have to use the Eilert rule. So according to that Eilert rule, we have to take the exponential function as the second function and the trigonometric function should be the first function. So therefore this should be cos x into integral e power minus x dx, then minus integral d by dx of cos x, then into integral e power minus x dx, then whole integral dx. Here actually we are using the rule of integration by parts. The rule is that the rule of integration by parts is that integral of u v dx, where u and v both are functions of x. So if we take v as the second function, u as the first function, then this would be u integral v dx. Sorry. The rule is u integral v dx minus integral du by dx into integral v dx, then whole integral dx. So this is the rule which we have to use for integration by parts. Integration by parts. So this rule we have to use. So if we use this rule, then we will get, this is cos x and integral e power minus x dx. So that would be e power minus x by minus 1, e power minus x by minus 1, and minus d by dx of cos x is minus sin x, and this would be into e power minus x by minus 1 and integral dx. So this would be equal to minus cos x into e power minus x, then minus this would be integral sin x into e power minus x dx, Then here also we need to take e power minus x as the second function and sine x as the first function. Here also we will apply this rule, which is the integration by parts. Okay, so this would be minus cos x into e power minus x, then minus this would be sine x into integral e power minus x dx, then minus integral d by dx of sine x into this would be integral e power minus x dx, then whole integral dx. Sorry, here we have to use the second bracket. We need to use the second bracket here. Sorry. Need to use the second bracket here. Okay. So then, so therefore the integral I, that is coming as minus cos x e power minus x, then minus this is sine x integral sine x e power integral e power minus x dx, then minus integral d by dx of sine x, then into integral e power minus x dx whole integral dx. So this would be minus cos x e power minus x minus this would be minus e power minus x into sine x. Then this is minus d by dx of sine x is cos x, and this is minus e power minus x into cos x, then dx. Okay, so minus minus is plus, so this will be minus cos x e power minus x. So this I integral, this is coming, then plus e power minus x into sine x, then minus of minus is plus, plus of minus, this is again minus integral e power minus x into cos x dx. So this is again I. So therefore we can write it as 2i. 2i is equal to e power minus x into this will be sine x minus cos x. So therefore this integral I, this will be equal to sine x minus cos x by 2 into this will be e power minus x. So hence the general solution here, the general solution is asked. Therefore, hence the required general solution of the given linear differential equation is y, it is y into e power minus x, it is y e power minus x, that is the integral I plus c. So that would be, that is equals to sine x minus cos x by 2 into e power minus x plus c. Or we can write it as y equals to sine x minus cos x by 2 plus c into e power x, where c is some arbitrary constant. So this is the answer. And then one more example we can solve. Suppose it is being asked, suppose here it is asked to find the particular solution, find the particular solution of the differential equation, which is dy by dx, then plus y cot x, that is equals to 2x plus x square cot x, where x is not equal to 0. And it is given that, it is given that y equal to 0 when x equals to pi by 2. So here, this is a linear differential equation. This is obviously a linear differential equation, which is of the form dy by dx plus py, that is equals to q, where the function p is the function of x, which is cot x, and q is 2x plus x square cot x. So now, therefore, the integrating factor will be e power integral p dx. So that would be e power integral cot x dx. And integral cot x is log mod sin x. So this will be e power log mod sin x. So this will be nothing but sin x. So integrating factor is sin x. Therefore, the general solution of this type of differential equation, the general solution is given as y times the integrating factor, that is equals to integral q times the integrating factor into dx plus c, obviously. So then, so therefore, the general solution of this differential equation will be y times the integrating factor, which is sin x, that would be equal to integral q, which is 2x square, sorry, 2x plus x square cot x into sin x dx plus c. So this we can write it as y into sin x, that is equals to integral 2x sin x dx, plus we can write x square. So cot x is cos x by sin x. So sin x will cancel. This will become cos x. So x square cos x dx plus c. So now this we can write it as y into sin x. So that would be equal to, so integral. So here again we have to integrate by parts. This we can do integration by parts, means we have to use the Eilert rule. Eilert rule says that it is inverse, logarithmic, algebraic, trigonometric, and exponential. So we need to take the algebraic function as the first function and the trigonometric function. So trigonometric function here in this case, we can take it as the first function, and the algebraic one, we can take it as the second function. Since here we have x square cos x, so that will get cancelled. That is why. Okay, so here, so this will be sin x into integral 2x dx plus then minus this will be integral d by dx of sin x into integral 2x dx whole integral dx, then plus integral x square cos x dx plus c, obviously. So this will be equal, so this implies it will be y sin x, that is equals to integral 2x dx, so that will be x square into sin x, then minus this will be equal to d by dx of sin x is cos x, so this would be cos x into integral 2x dx, so that would be x square into dx, then plus this is integral x square cos x plus c. Okay, cos x dx is there. Okay, so these two will get cancelled, you can see there. So this will become y sin x equals to x square sin x plus c. So this is the required general solution, but here the particular solution has been asked. So here it is given that y equal to 0 when x equal to pi by 2. So x equal to pi by 2 when y equal to 0. So this we can put, so this we can put here and find the general, we can find the particular solution. So therefore, y is 0, 0 into sine pi by 2. Sine pi by 2 is 1. So that is equals to x square, which is pi by pi by 2 whole square into sine pi by 2 plus c. So sine pi by 2 is 1. So c plus pi square by 4, that is equal to 0. So c equal to minus pi square by 4. So therefore, you can say the required particular solution, of this given differential equation is y sine x, that is equals to x square sine x minus pi square by 4. Or we can write it as y equals to x square. From here we can divide by sine x on both sides, actually. Divide by sine x. So this will cancel if a sine x is not equal to 0. So it will be y equals to x square minus pi square by 4 sine x. So this is the required the particular solution. And here sine x should not be equal to 0, provided that sine x should not be 0. It means, or you can say that x should not be equal to n pi, where n belongs to z. So this is the final answer for this. Thank you.